have a couple of different tests over here. You guys get to choose if you want to do the easier test or the harder test. Harder. Alright, so here's the beta bottle. Now, since these are the aerodynamic models, we're going to put them in a special case right over here. So this case over here simulates sort of the foundations of the building, so the building doesn't fall over. As opposed to the easier tests, these are called the knockdown models, so you just place them up and see what's going to happen. Now, as you take a look right over here, this is our special console that we use for the aerodynamic models. The graph over there, like if I agitate whatsoever, you'll see lines. Also, you'll be able to see exactly how much the building is swaying on average and what the maximum sway is. When the wind stops blowing, it means that the building would have fallen down. So we're going to see what happens. And right now, if I try to lift it, I won't be able to because it's actually a vacuum suction that's holding the building down. Take a look at the lines. You'll notice that the shape of the lines is actually changing from being circular, and you can actually see exactly how much the building is swaying. So the maximum it has swayed thus far, it's actually still increasing. It's at 22 feet right now, meaning if this was a real building, it would have swayed 25 feet from one end to the other, and it's still standing. Anybody want to take a guess at how much the World Trade Center buildings were allowed to shake before they fell? 25. Lower.
15.
8.
8.
It allowed an 8-foot sway before the building would have fallen down. Falls around 45, right? There you go. Alright, so in physics it's called resonant frequency, meaning each material has its own frequency. So the frequency with which the wind was moving actually matched the frequency with which the buildings were made out of. So whenever that happens, you have a huge disaster, like the disaster that occurred with Tacoma Bridge in Washington. Before that bridge actually fell, you could see the bridge swaying up and down, twisting and turning. Now that bridge was built very stable. It's one of the best architectural pieces that were built. But the architects forgot to think about the resonant frequency. So one day the winds came in very fast, they stopped. Came in very fast and stopped. So over time the bridge itself started to sway up and down, twist and turn before it actually broke. YouTube has a video of it online.